Okay, so we are going to start off by solving systems of equations by graphing. So looking at our equations here, we've got 5x plus y is equal to 4, x minus y is equal to 2. Before we can actually graph these, we need to have them in slope-intercept form. So that's y equals mx plus b. So for the first one, I have 5x plus y is equal to 4. This one isn't too hard. All I have to do is subtract the 5x from both sides. So I get y equals, and then remember I want the x to come first, so I'm going to take my negative 5x here. That'll be my first term. And this is a positive 5, so I'm going to say a positive 4 plus 4. The second equation, x minus y is equal to 2. I'll start off the same way that I did my first. I'm subtracting the x from both sides. So I end up with negative y equals negative x plus 2. And then to change this y into a positive, remember there's a number in front of y here. This is just a negative 1. So what we're going to do is we are going to either multiply all of the terms by negative 1 or divide all the terms by negative 1. Either way, we will end up making this positive. And by doing that, all we're really doing is changing the sign of everything in the equation. So my y is now positive, my negative x is now a positive x, and then my positive 2 is now a minus 2. So here's my second equation, my first equation, and now I just need to graph them. So I start by graphing the y-intercepts. So the y-intercept for the first equation is a positive 4. So I will go up to positive 4 on my y-axis and plot a point. The slope for this one is negative 5. And remember, if it's a whole number, to turn it into something with like a rise over a run, we just put it over 1. So we're going down 5 to the right 1. So starting from 4, our first point we plotted, down 5 to the right 1, and we plot a second point. And then we are able to draw in our line. Okay, the second line, y is equal to x minus 2. Again, starting with the y-intercept, so I start at negative 2 on my y-axis and I plot a point. My slope, there's not a number in front of the x, it means it's a 1. And if we have a whole number, we put it over 1. So starting from the slope, I'm going up 1 over 1, up 1 over 1. And I just plot my points there. So up 1 over 1, up 1 over 1. And then I'm able to draw in my line. Alright, let's try to make that a little bit better. Okay, there we go. Alright, and then the final solution is wherever the points meet. So remember, if we have them meet at one point, it's one solution, and we name the solution. And it looks like that's what's going to happen here. Our solution then is at 1, negative 1. So that's our final answer. If we ended up with parallel lines, so if we had two parallel lines, that's when we have no solution. And then if we have two lines that are coinciding, they're just graphed on the same line, that's infinitely many solutions. So in this case, we ended up with one solution, so we name the solution. Okay, for the next few problems, we're solving either by substitution or elimination, and most of the problems on the test you are going to be able to choose. So for this first one, I am going to go ahead and rearrange my second equation. I'm going to do this by substitution. So substitution says that we have to get a variable by itself first, so that's what I'm going to do for my second equation here. I'm going to subtract the 4x. I get negative 2y equals negative 4x plus 22. And then I divide by negative 2. So y is equal to 2x minus 11. Okay, so after I isolate the variable, whoa, that looks awful. After I've isolated the variable, I'm going to take the 2x minus 11, and I'm going to plug it in for y in the second equation. Okay, so I'm going to take 2x minus 11, plugging it in for y. Alright, so what that'll look like then, negative 7x plus 7, and then I'm opening up a set of parentheses. I'm plugging in 2x minus 11. And then we just solve for x from here. So, distributing. Combining like terms. Adding 7 to both sides. And we get 56. And then dividing by 7, we get x is equal to 8. So we know what x is, we just need to find y. And to do that, we can plug it into either one of our equations and solve. So I am going to plug it into the second equation. Okay, so 4 times 8 minus 2y equals 22. So we get 32 minus 2y equals 22. Subtract the 32 on both sides. We get negative 2y equals negative 10. And then finally dividing by the negative 2. I end up with y equals 5. So after I have both x and y, I write it as an ordered pair. So 8, 5, and I'm done. Okay, for the next one, I'm going to solve this by elimination. So remember, for elimination, we want to either have opposite coefficients so that we can add the equations together, or we want to have the same coefficient in front of our variables so we can subtract the equations. So for this one, it looks like it wouldn't be too hard to change these, either the x's or the y's, into opposites. I've got 2x and negative 6x. There is a number that I can easily multiply by 2x to give me the opposite of negative 6x. I'm going to take that equation and I just want to multiply by 3. So 3 times 2x gives me 6x. 3 times negative 4y is negative 12y or minus 12y. 3 times 20 is 60. So this is what I wanted. I wanted a negative 6x and a positive 6x. So I can add my equations together now. So negative 6x and positive 6x cancel out when I add them. That's where the elimination part is. Y and negative 12y, that's going to make negative 11y when I add them together. And 60 plus 6 is 66. So then I divide by negative 11. Y is equal to negative 6. And then to find x, I take that number and I plug it into either one of my equations. So I am going to plug it into my first equation. So 2x minus 4 times negative 6 equals 20. So 2x plus 24 equals 20. Subtract the 24 on both sides. 2x is equal to negative 4. Divide by the 2. So I end up with x is equal to negative 2. And then remember, I need to write it as an ordered pair, x, comma, y. And that's it. Okay, I'm also going to solve this one by elimination, but this one's going to be a little bit more complicated. Remember, we need either opposite numbers, opposite coefficients in front of one of our variables, or the same coefficient. For this one, it's not really easy to get from 6 to 8. There's not really a number I can multiply, at least not a whole number I can multiply to get from 6 to 8. Same thing to get from 4 to 6. So what I'm going to have to do is I'm going to multiply both of the equations by something. So my first equation, I'm going to multiply this whole entire thing by 6. I multiply it by the coefficient of the number in the opposite equation. So right now I'm eliminating the x's. So I multiply this one by 6. So 6 times 8x is 48x. 6 times 4y is 24y. And 6 times negative 20 is negative 120. Then I'm going to take the bottom equation. I am going to multiply that whole thing by the coefficient of the number in the opposite equation. And you can do this one of two ways. If we multiply by a positive 8, we would end up with positive 48x, and so on. And what we would do is we would subtract the two equations. So another way to do this is to multiply by negative 8. Whoops, not what I meant to do. Okay, multiply it by negative 8. So that way when I do that, negative 8 times 6x is going to give me negative 48x. And then minus 48y. And then negative 8 times negative 18 is positive 144. So what I've done here is I now have opposites instead of the same number. If it's the same number, we subtract them. Since they're opposites, we get to add the equations together. So 48x plus negative 48x, that's where the elimination comes in. 24y plus negative 48y is negative 24y. And then negative 120 plus 144 is 24. So then I can just divide by the negative 24. And I end up with y is equal to negative 1. After I have my first number, I just take it and I plug it in for either of my equations. Plugging it in for y. So I'm going to plug it into the first equation. So 8x plus 4 times negative 1 is equal to negative 20. So that's 8x minus 4. Whoops. Equals negative 20. I add 4 to both sides. And I get negative 16. And then dividing by 8, I end up with x is equal to negative 2. And then finally, remember, we write this as an ordered pair. So x, my negative 2, comma, negative 1. Alright, so next we're looking at one solution, no solution, or infinite solutions. To determine the number of solutions, they have to be in slope-intercept form. So I will take the first equation, and for the first equation to be in slope-intercept form, I just need to move this x over. So I end up with y equals negative 7x plus 13. For the second one, I subtract the 28x. I get 4y equals negative 28x minus 2. And then I just divide all the terms by 4. Remember, the point of doing this is to isolate the y. We're trying to get the y by itself, so that is our goal. So anything that's on the same side as y needs to be moved. Okay, so I end up with the same slope and different y-intercepts. Same slope and different y-intercepts mean that they are parallel lines and they have no solution. Okay, doing the same thing that we did for the last one, just trying to get y by itself. We start by adding or subtracting anything that's separated from the y by a plus or a minus sign. So starting with the x. So I subtract the 2x. And I end up with negative 3y equals negative 2x minus 15. And then I divide by the negative 3. And I end up with y equals 2/3 x plus 5. For the second one, same thing. I start by moving the x. So this time I'm adding 2x to both sides because it's a minus 2x. So I end up with 3y is equal to 2x plus 15. And then I divide by the 3. So y is equal to 2/3 x plus 5. So what we end up noticing here is that these are actually the same equation, the same slope, the same y-intercept. So that means that these are or have infinitely many solutions. Okay.
Try to make it look pretty.
And then finally, for the last one, again, moving the x over first, we get 2y equals negative 2x minus 10. And then I divide by the 2. We have to put them in slope-intercept form first, so that's what we're doing. So we end up with negative x minus 5. And then for our second one, doing the same thing, moving the x first. I end up with 4y equals negative 4x minus 16. And I divide by 4. So I end up with y is equal to negative x minus 4. So again, we have the same slope, different y-intercepts. This is going to be no solution. Okay, and now we're looking at a couple of word problems. So for the first one, the school that Stefan goes to is selling tickets to a choral performance. On the first day of ticket sales, the school sold 3 senior citizen tickets and 1 child ticket for a total of $38. The school took in $52 on the second day by selling 3 senior citizen tickets and 2 child tickets. Find the price of the senior citizen ticket and the price of the child ticket. So the first thing we have to do is identify our variables, what we're looking for. So we're looking for the senior citizen ticket price and the child ticket. That's going to be our x and our y. Next, we are going to just break down the sentences one at a time. So the school that Stefan goes to is selling tickets to a choral performance, so they don't really give us any information there, just that they're selling tickets. On the first day of ticket sales, he sold 3 senior citizen tickets and 1 child ticket. So I need to represent 3 senior citizen tickets. And my senior citizen tickets are x, so 3 of them will be 3x. The child tickets, I sold 1 child ticket, so y represents the price of the child ticket, and I sold 1 of them, so plus 1y, or just plus y, equals, and they sold for a total of $38. So there's my first equation. And then the second one, the school took in $52 on the second day by selling 3 senior citizen tickets and 2 child tickets. So just like I did the first time, 3x plus 2y was equal to 52. And then after I have that, I can go ahead and solve. So it looks like this one is sort of set up for elimination already. We've got 3x and 3x. Anytime we have numbers that are the same, we are going to subtract. To eliminate when the numbers are the same, we subtract. So 3x minus 3x, that's where the elimination comes in. 1y minus 2y, that's going to be negative 1y or negative y. And 38 minus 52. 38 minus 52 is going to be negative 14. And then we would just divide by the negative 1. So y is equal to 14. So we just remember what y stood for. Y was the price of the child ticket. So this is actually dollars. So the child ticket is $14. To figure out what the x is then, we're just going to take y and plug it in. So I'm taking 14, I'm going to plug it into either one of my equations. So I'm going to use the first one. So 3x plus 1y or plus y equals 38. Plugging 14 in for y. So I subtract the 14 from both sides. I get 24. And divide by the 3. So I end up with 8. So then we just have to answer a question. Find the price of the senior citizen ticket and the price of the child ticket. The senior citizen ticket is $8 and the child ticket is $14. Okay, and then looking at the last problem here, this is another word problem. Matt and Ming are selling fruit for a school fundraiser. Customers can buy small boxes of oranges and large boxes of oranges. Matt sold 3 small boxes of oranges and 14 large boxes of oranges for a total of $203. Ming sold 11 small boxes of oranges and 11 large boxes of oranges for a total of $220. Find the cost of each one small box of oranges and one large box of oranges. So, first step is to figure out what our variables are. And I think in this problem it's probably pretty clear. It says that they can buy small boxes of oranges and large boxes of oranges, and then it goes on to say the same thing. So it looks like those are going to be our 2 variables. We are looking for the cost of the small boxes of oranges, we'll call that S, and the large boxes of oranges, we'll call that L. Okay, so 3 small boxes. Matt sold 3 small boxes of oranges and 14 large boxes. So we represent that as 3S. And then he also sold 14 large boxes, so 14L. And he sold them for a total of $203. And then Ming, it says Ming sold 11 small boxes of oranges and 11 large boxes of oranges. So 11S plus 11L, and the total for that one was $220. And then we want to find the cost for S and L. So we're solving for S and L. So we have 3S plus 14L equals 203. 11S plus 11L is equal to 220. And you can solve using elimination or substitution. So since I like elimination better, I'm going to go ahead and do elimination. So I'm going to take my first equation. Since I don't have opposites, and I also do not have the same number. I've got a 3S and 11S, so that doesn't really help me. 14L and 11L. So there's nothing I can multiply by 3 to get me 11, and there's nothing I can multiply by 11 to get me 14. So what's going to end up happening is I have to multiply both of my equations by some number. So I'm going to multiply the first equation by the coefficient of the number in the opposite. I'm going to eliminate the S's just because they're on the left side, and that's just easier for me to visualize since I read from left to right. So I'm going to go ahead and get rid of those first. So I'm going to multiply this whole equation by 11. So I end up with 33S plus 140 or 54Y or L equals $2,233. And then I'm taking my second equation, and we're going to multiply the entire second equation by the coefficient of S in the first equation. So I'm multiplying by 3. Whoops, 3. Okay, so 3 times 11S is going to be 33S. 3 times 11L will be 33L. And then 3 times 220 is going to be 660. So now that I have the same number here, I can go ahead and eliminate. So when they're the same number, we subtract to eliminate. When they're opposites, that's when we add. So in this case, since they're both 33, I'm going to subtract. So 33S minus 33S, that's where the elimination comes in. 154 minus 33 is 121. So this is 121L. And then 2,233 minus 660 is going to be 1,573. And then my last step is to just divide by the number in front of L. So I divide by 121, and I end up with L is equal to 13. So I know that the large boxes are $13. To figure out what the small boxes are, I am going to take 13 and I'm plugging it into either one of my original equations. So I'm going to go ahead and use my first equation, 3s plus 14L equals 203. And I'm just plugging in 13 for L, so 3s plus 14 times 13 equals 203. And then from here, we're just solving it down for s. So that's equal to 182. We subtract the 182 on both sides. We end up with 3s equals 21. And then dividing by 3, we end up with s is equal to 7. Okay, so it looks like our large boxes, to answer our question, the large boxes are $13. Our small boxes are $7. Okay, and I hope this helps you guys for the test tomorrow. It's going to be over graphing, elimination, substitution. So as long as you can do those 3 things, you should be completely fine. There are a couple of word problems, so you will need to know how to do those, how to set them up and then solve. Good luck on the test, and make sure you study.